So welcome everybody to this session. Today we will be talking about how pure design of your API is not sustainable for your business. So the agenda for today, we will see what's the impact on our business when APIs are designed poorly. We will then talk about code first and why sometimes it's not the best approach. We will then introduce a new way of delivering applications and APIs called API first. And finally, we will introduce the design first approach and some of the benefits which the design first approach also brings. I will then do a short demo to introduce Gravity Visual Designer, which allows to design API contracts in a visual way. So let's get started. So we're going to talk about API design, but what is API design in the first place? When we talk about an API design, we typically refer to the set of contracts that the API exposes. These are, for example, endpoints, security schemas, object schemas, and so on. Without a well-defined API design and without such design being made available to developers, those developers will really struggle to understand what the API does, what are the API capabilities. They will get frustrated, and probably they will go their own way and maybe implement another API, or even worse, they will try to connect directly to those backend systems holding the data they need. The net result of this is there will be a higher operating cost and delivery cost, obviously because you will take more time to deliver those applications. This will lead also to a bad developer experience, which eventually will lead also to a bad employee satisfaction. Now, companies that continue to dismiss the importance of a good API design will be left in the dust by more innovative competitors. So in this presentation, we'll discuss the problems that adopting a code-first approach might present to organizations and how a new shift is helping organizations to support a more sustainable business operation. So what is exactly code-first approach and what are the implications of adopting such an approach? With a code-first approach, we refer to an approach in delivering API strategies whereby the implementation starts as soon as the business requirements land on the table of an API developer. In a code-first approach, once the requirements are gathered, the developer will start straight away building the API implementation, and only once it has been deployed, the documentation would potentially be produced, typically by using automation tools which will, for example, scrape the code. Now, the code-first approach typically is adopting when developing APIs that require a very quick deployment time and with a relatively small scope. Now, in my experience, this approach works for small teams, teams that need to deliver really technical and internal API that are only meant to be consumed sometimes by the same developer which are building both the API implementation and also a consumer application. Think about microservices, where normally you have the same developer building different microservices, and they will build both microservice exposing the API and also the microservice which will consume the API. These are sort of APIs that are mainly built for a single use in mind. This means that the intrinsic value of such APIs is relatively small, being used by for a single purpose. So there is not real reuse taking place, which is, in my opinion, one of the main benefits of APIs. APIs are, I wouldn't say useless, but their real value really goes down unless APIs are used by more and more clients. So let's see some of the drawbacks of adopting a code-first approach. First of all, no documentation. And that's because developers are really focused on deploying the API implementation. That's all they care about. That's what they actually like to do. And this, as I mentioned, there will probably be the same developers who also will consume those API, and they might not be bothering creating documentation at all. Another drawback is, obviously, as a result of that, is an increased cost. This is due to many factors, actually. The fact that the feedback loop is much slower, for example. So if you want to make any change to the API, you will need to implement the API, deploy the API, someone will give you feedback, and then you will need to go back to the code, redeploy, re-implement, and so on. So it will take much longer to make any change to the API definition. Obviously, you will get a poor developer experience. Having APIs that are mainly driven by technical constraints and are poorly documented means developer will find it really difficult to use these APIs. More often than not, as I mentioned, this developer will prefer to build maybe their own version of an existing API, which essentially will leads to an increased cost because this developer will start spending time on building something which already exists. And finally, what's going to happen is API and contract will start to drift apart. Even if the developer is producing documentation, it will be very likely that a small change to the API, so imagine they ask, for example, to add a small field to a payload, won't be reflected in the documentation. Now, if you multiply this several times for several small changes, you can see how over time, the documentation will start to look very, very different from what the API actually provides. Now, I wanted to stop here and ask Markus a very small question. Do you have many customers who are still adopting this approach? And do you think what I'm reflecting here in terms of when code first is applied matches the reality?
Yeah, I definitely think so. So there are really few customers around that stick to that approach. And I think most of the time the reason is a false sense of agility, right? So they don't want to bother with planning, with getting their design right. They just want to dive in directly into the code. And I think the biggest issue here is that, you know, your code gets kind of its own life. So you're not developing for the purpose anymore, but you're developing for the sake of the code. And most of the time, the solutions these customers come up with are, you know, they are great from a technical point of view, but they are not especially very well suited for the task that they try to solve at first hand. So yes, we see that with our customers, and we still have a long way ahead of educating everyone that there is a better way of working. So yeah.
And just to give you my personal experience, I was working with a customer a few years ago, and obviously they were adopting the same sort of approach. And when we stepped in, what we found out, they had 6 versions of the same GET address API. And that's because they didn't have an API strategy. Everyone needed a way to look up for an address, and they were building their own API all the times. So eventually we were able to condense 6 versions of this API into a single asset, which is much easier to operate. It's also cheaper because you don't have to implement that piece of code every time you need it. Great, thank you very much, Markus. So there is a new way relatively new way to deliver API strategy. Sometimes we tend to, when we talk about delivering API, we tend to mix API first with design first. But let's make a distinction because they are actually 2 different things. In the 2021 State of the API survey, Postman questioned over 28,000 professionals of the API industries, people like developers, testers, executives, and so on. And they questioned them about embracing API first strategy. The result is that over 60% of these people responding to this survey rated their adoption between 5, which means we are somewhat API first, to 10, so we are fully API first. But even if the majority of industry members are adopting this strategy, the term API first might mean different things to different people. It can be used, for example, to refer to developing APIs before developing applications or integrations. Some people may refer to API first as defining and designing APIs and schema before beginning the implementation. So let's clarify and define exactly what API first means, and you will see that it's different from design first. So delivering an API strategy by adopting an API first approach means the API are considered first-class citizens, which means everything you are developing is developed with the end goal of API consumption in mind. In an API-first development, API are no longer an afterthought, but they are actually a differentiator. Producing an API every time a new project is delivered brings many positive benefits. First of all, reusability. So once an API has been developed, that data, functionality, business process encapsulated within the API logic can be leveraged by other application, other maybe line of business, things you at the moment you're even thinking about. Since APIs have a wide reach, collaboration between different teams within potentially different business units becomes extremely important. And this will increase the collaboration across different teams, which will result in an improved communication across the organization. Once APIs have been built, the next project using the same API can be delivered faster, reducing not only the development cost, but also the time to market. So we talked about API first and how it focuses on considering API as first-class citizens. Now, that is different to how you can actually deliver an API. So you can be API first, but still do code first. Adopting a design-first approach really changes the way APIs are delivered. You won't have a developer jumping straight to the code, but you focus on first what business capability the API needs to deliver. This is the only way you can make an API easy to consume and ultimately render your business more sustainable. So let's now visualize how this process works. So how you would deliver an API adopting a design-first approach. So talking about the API lifecycle, let's analyze how the API lifecycle looks like when adopting this approach. When a new API lands, like a new requirement lands on the developer table, the cross-functional teams will start to discuss the API design. They will agree on the API requirements, security, capabilities, and so on. This obviously is an iterative process which might involve different stakeholders like engineers, business analysts, enterprise architect, you name it. Once everyone has agreed on the actual design, you have a design, and at this point, lots of things can happen in parallel. For example, you could start pushing the API documentation on a portal, so people can start already provide you with feedback. You can also use the portal, the contract to expose mock data. This has several benefits, which I will show you in a bit. You can also use the contract to start stubbing, for example, API implementation or even potentially API clients. And finally, while the API is being implemented, you can also start managing this API in terms of applying security, traffic shaping, and so on. Now, the benefit of the contract and the benefit of all these tasks is that you can actually leverage parallel development, because you can use, for example, the mock service to have a backend developer working on the API implementation and the automated testing, while at the same time, a front-end developer can start working on the actual API client implementation. So, Markus, does this approach resonate with you, and does it fit with what you actually deliver when you work with customers on their API strategy?
Yes, absolutely. I think this approach is, it's a great combination of being more user-centric in a sense that what you really want to solve in the first part, so your ultimate outcome, is to solve the business problem that you are trying to solve, right? So, I mean, we are not creating APIs, we're not creating software for the sake of it, so it always has a purpose. And I think doing the discussions and the design first really focuses on solving that business problem. And after we solve that, by having a clear contract that everyone can follow, the biggest improvement to the code first approach is that you can work in parallel And as you said, right, the front-end development can work against the API with the mock data. So front-end development is not slowed down by any errors or any stuff that is happening in the backend. And it's also a very, modern and agile approach in the sense that you're not focusing on the technical implementation in the front end, in the back end. So you really focus on just the contract, and every team can then do their best work against that contract. But you always guarantee by fulfilling that contract that the business goal is ultimately solved. So yes, I think this is the right approach to use. And we very much, educate our customers on that approach. At first, sometimes it feels counterintuitive to, just wait and not get going from the start go. But it pays big time in the long run, and that is basically what we're talking about, right? So you want sustainable pace, you want sustainable quality in your API strategy, in the delivery of your strategy, and that is the way to get there.
Yeah, in a way, it's like the agile versus waterfall approach. So instead of building the whole thing and then getting your feedback, you can start getting feedback straight away. And that's one of the benefits of parallel development. It's not just making the implementation faster, but also you can have this front-end developer start to give you feedback still before you even started the implementation. So eventually you will get with an API which is already meeting all the requirements instead of having to go through several iterations.
Exactly. And these fast feedback cycles, they really help you because you can then make adjustment to the contract if needed, right? So if the front end starts after the back end has finished its coding and then they want to change something, well, then you have to change the contract and the implementation. And doing that design first and leveraging all that mocking stuff or just discussions, so you get that change in the contract very early on, and so maybe backend hasn't implemented it at all, and so they don't need to change anything. So yeah, the fast feedback cycles are really a benefit of this.
Yeah. Okay, so now let's look at some of the benefits, and probably some of the benefits I'm gonna show in the slide is stuff we already discussed in this quick conversation. So the first advantage of design first is obviously an improved. Sorry, my phone was ringing. I lost my audio. So the first benefit is obviously improved communication with all the project stakeholders, from business members to technical members, or even customers sometimes, in order to get a rapid feedback loop, and also be able to iterate quickly over the API definition, as essentially we just mentioned. By shortening the feedback loop and making work even more visible, teams are able to mitigate risks and somehow also reduce cost. Gone are the day when you had to rework your API until you get it right. Rework that might include coding, testing, integration, running pipelines, and so on. And if you think about it, is the kind of benefit of the agile methodology versus the waterfall cycle. And this is also extended to the design phase. Another advantage of this approach is that the defined API would be more compliant to the client's needs and more product driven, as you mentioned, Markus. Instead of having APIs that stick to the development constraints like data storage or authentication and permission. This will eventually provide a better developer experience for both the developers, who obviously needs to stick to the API contract and try to implement an API which provides the functionality the contract defines, but also to the consumers of the APIs. So having a contract, they will be able to easily understand what the API does, how to invoke it, and so on. And as we have seen in the previous slide, design first really helps to deliver parallel development by being able to start both the backend and front-end implementation at the same time. And also by providing some mocks that can be used to develop front-end applications or to start writing some automated testing without having to wait for the API to be deployed. And finally, Designing API prior to the development can also help enforce governance and security by defining some global settings and best practices, like, for example, the instance name conventions or case configuration, security schemes, default responses, depending on the status code, and so on. There are some tools to apply checks on API specifications. So just like you use, for example, linter on your source code, you can also use tools to enforce quality rules on your APIs. Now, you can adopt a design-first approach by asking developers to craft, for example, an open API specification contract. This is quite difficult to understand and share across non-technical stakeholders. At the end of the day, what we mentioned before is that one of the benefits of design first is the ability to have technical and non-technical people collaborating in designing an API contract. Now, that could be really difficult if we ask, for example, a business analyst to type some open API specification. So you really need a tool which allows you to collaborate with the non-technical people in designing something which is kind of detached from our open API specification. So for this reason, Gravity built a new capability which allows technical and non-technical people to design an API contract using a free mind approach. And I just wanted to show you quickly how that would look like to a user of the Gravity platform. So what you can see on the screen, this is an API definition for example, a bank account. So in this definition, as you can see, there is nothing which really relates to open API specification. What we are focusing on is the capabilities and the data which this API would provide. So in this schema, we are defining accounts endpoint, which would allow an application to query for one account or maybe to access the detail of a specific account. And for that account, we also want to get the balance. Now, for each one of these endpoints, we might want to define certain method, which in OpenAPI on invest parlance, that would be a get, post, patch. But this doesn't really mean much to a business developer, the business analyst. So what Gravity provides is an intuitive way to define what action are available on an entity. So for example, for a balance, I might want to only enable the creation of a balance, not an update, or maybe a deletion actually. We might want to enable a partial update. So this will allow the API to only update certain attributes of the balance entity. If we are talking around the accounts entity, we might also want to allow searching for an account. So maybe we want to allow to search for a customer ID. Very importantly, for each one of the attribute of an schema, you can also specify, for example, when this attribute will be available on the request and on the response. You can also specify examples, and these are very important because this is exactly the data which will be provided by the mock service when the API is deployed prior to its implementation. So let's assume, for example, we want to add a new sort of endpoint, which is mortgages. So when I add an entity at the root level, this will become automatically a resource. So now what we can do is to change the name to this endpoint and call it mortgages. And then we can add a bunch of attributes. So let's say we want to add an ID. We want to add a name of the product. Obviously, this is going to be string. The ID, maybe we can make it a number. And then we can specify also a value like 1, 2, 3. And finally, we can say in which country this mortgage has been created. And this, again, will be another string. You can also use color to, for example, to also manage the life cycle of your contract. So if, let's say, mortgage, it's still a work in progress, I can say this is still draft. And each attribute can also be marked as draft to signify that this still requires, for example, stakeholders validation. Now, I've been able to add this new endpoint pretty much in 3 minutes. And what you can see behind the scene, Gravity has created this Swagger definition. That's what a developer would have needed to build manually. So you can see how I was able to add a new mortgage object schema with all the relevant method without typing anything. So you really can have business and non-business people working on API specification. So Markus, I wanted to ask you, what's your experience around the design first approach using OpenAPI specification, and whether this tool you think could be useful for the type of organizations you work for?
Yes, I definitely think this, this kind of tool with a very visual representation and a very intuitive way of working and creating these specifications will help customers, because what you have most of the time is that, like exactly you have in your tool, people start mind mapping, how it should be set up, and probably they do it on a whiteboard, and then someone has to transfer it to digital. Then the developer takes over, brings it into spec format, and just there's a lot of time lost. And the way you do it within Gravity is basically you can discuss right in the platform, you can do changes right in the platform, and you have immediate results. So it really shortens, it shortens the feedback loops, because you're all on the same page. You can work on it collaboratively. And a lot of non-technical people, at least at the companies we work, they are like, afraid of writing anything that resembles code, right? So, I mean, you can use YAML, which doesn't exactly look like code, but it still feels like code. And so there are a lot of people that are hesitant to do so. And what they usually do is they just go ahead and think of, how can I do it for myself? And then they come up with like images or, worst thing, Excel spreadsheets or whatever. So it just adds additional steps, and introducing a tool like this, brings everyone closer together, and gives everyone a shared ground. Because if you have developers in the meeting and they're like, yeah, this mind map is like nice, but they switch over to the Swagger definition and they feel right at home, right? So this is, I think, a huge benefit for the design first approach.
Yeah, I mean, typing the OpenAPI specification could actually be a barrier, in my opinion, to design first. Because you can't take a OpenAPI specification and share it with a business business analyst, and expect that person to be able to provide feedback straight away. Well, you can very easily share this with pretty much anyone, and everyone who, for example, is a domain expert would be able to tell you straight away whether any of these endpoints make sense for that specific domain, which is honestly quite difficult to do without a visual representation of what your domain and the API actually represents.
Yeah, and I also think the visual representation helps you to find inconsistencies, right? So because you have everything on one screen, you have everything, you can really look at it and just see it from top-down view. The most important stuff, like how is it named and so on, maybe do some color coding. So this is really easy to find inconsistencies. Just make sure it's a pleasant experience to work with that API, and you don't have that if you work exclusively on the spec.
Yeah, very good point. The OpenAPI can be quite verbose in a way. So yeah. Okay, so now and obviously last part I wanted to cover is the Gravity Visual Designer also really cuts the time to start making your API discoverable, because from here I can now easily push my API directly as a mocked API. So I don't need to go through several steps in order to make my API available. So you can actually go from talking to your business analyst or domain expert around the API model, and then say, okay, let's see what our new audience actually say, and push your API directly on the portal, so other people outside the organization potentially can provide you feedback to see whether your expectation actually match the customer expectation. So that's another way to speed up the API lifecycle. Okay, so that's the end for me. In conclusion, adopting a design-first approach in delivering API strategy will definitely help organizations to operate more efficiently, reducing waste and also cost, and increasing the application delivering throughput. So essentially, the number of applications organizations will be able to deliver, which will make you stay ahead of the competition. So that's the end of the session, and thank you everyone for joining us today.
Okay, so Nico, should I take over then from you?
Yeah.
Yes. Okay. Then, as you might have noticed from, just look at it, yes. So as you might have noticed from the definition in the agenda, this is a joint session of Gravity and Apiida. And just to make sure everyone knows who we are. So probably Gravity right now as one of the most innovative open source based API management platforms there is, with a huge momentum in the market right now. And we know that because we are a Gravity partner. So Apiida has partnered with Gravity. And we provide, solution engineering for the Gravity platform. And, we're talking to a lot of customers and how the implementations look like. And that probably is the reason, why we were really honored when, Nico and Gravity asked us if we want to do the session in a joint manner. And what basically is our goal is to maximize the return on API for our customers, right? So a lot of the time API programs do not deliver the value that the companies originally had in mind. And we are here to figure out why, to show you better approaches, to show you better ways of working, to integrate platforms within all of the other infrastructure that you have. So that you can really leverage these APIs. And in that second part of this workshop, we will be talking about what actually is a good API design. So as Nico showed us, it's important to do API first. It's important to do design first. There are really easy tools within the Gravity platform to make that work. And now you designed your API, right? So you have your first draft, whatever. So you have that specification, and now there is the question, okay, is it good? Because the topic of the workshop is poor API design isn't sustainable. So obviously you want to know, is it good? Did I have a good API design or not? And the answer is like, if you ask a technician if something is good or if something is the way it should be, the answer is usually it depends, right? And it's the same with API design. So is it a design good? It depends. Well, what does it depend on? It depends on the audience. It depends on who you ask, right? So because there are different views on API design. And to just name a few characteristics of good API design, there's the technical view, right? So if you ask your developers, so is this a good API design? They ask you, okay, is it well defined? Is it machine readable? Is it complete? So is every endpoint mentioned therein? Are there any hidden endpoints? Are there arguments that are not in the docs? Is it even documented? Like, what Nico just showed you, okay, are there example values? Is every endpoint described and every resource described? What is it doing? What is it good for? Because usually the developers are not the domain experts. So they need to rely on the API design to tell them what things are, right? So that they can, build their mental model around it. However, if you ask someone from the business side, they usually have a whole different idea on what a good API design is. So their questions more resolve around, okay, what's the business case of this API? Okay, what use cases does it handle? Are there stories? What can I do with it, right? So they need to understand the mapping between the domain they work every day in to the resources in your design. They need to understand the relationship between each other. And another thing they will ask for is reusability, right? So now we're in, in the area where money counts. So Is it reusable? Can I, save costs by not reinventing the wheel in my different business units, right? So is it abstracted enough and documented enough so that anybody in the company can take it, right? So Nico had the example of, the developers coding the API that are also using the API. So only one consumer for each API. And this is not something that a business guy would consider to be good API design. And the third, archetype, if you will, that we identified is there is a view on governance, on corporate IT. What they want to know and what they want to, or what they look after in a good API design is, okay, does it look like the other APIs we have, right? So, or is every API different? Especially if you go design first, especially if you do these collaborative design sessions, where you have the domain experts chip in. Okay, but is the end result of that, is that comparable to everything else I have done in the company so far? Is it secure, right? So do I open up any security holes with that? For example, stuff like, can that mortgage be created or not, right? Can it be updated? Can someone, by fiddling around with the API, change his, this mortgage amount? You don't want to have that. And is it compliant to your guidelines? So these are, some characteristics that we identified. And Nico, maybe you have some more where to add to the list here.
Yeah, no, I think you cover pretty much everything. I mean, the only thing I can say is, first of all, the very basic, we are talking about REST APIs, so don't have an endpoint which says get accounts. So that's like very ABC of a good API design. Make sure you are talking about nouns rather than verbs. So that's the first point. And also, as you said, I think it depends on what the API does. One of the benefits of APIs, in my opinion, is to abstract away your backend systems. So always make sure your APIs are as far away as possible from the specificity of your backend system. So if you're building an API, for example, which is trying to abstract CRM people, and you're using Salesforce, don't try to design your API based on the fact you're using Salesforce, but try to use a model which is only based on your domain nouns rather than whatever Salesforce exposes. Because the benefit of that is one day you might want to move from Salesforce to HubSpot, and that will have zero impact on your API. All you have to do is to change the implementation. So that's my 2 cents on how a good API looks like.
Yeah, I fully agree with you there, especially on the abstraction. So I don't know how many of you are familiar with SAP, for example, and SAP is a German system, and as such, a lot of the core database tables, they have German names, and the fields have German names. And to make it even worse, it was created in the time where space was precious. So they are five-letter abbreviations of German words. And this is always funny when you work with people from abroad who really have a hard time understanding what that field does or what the table does. And I mean, I'm German, so for us it's straightforward. We just read it and say, okay, we know what this is. And everyone else just looks at me, how the hell do you know it? So yeah, it's German words. So you don't want to put that in your API as well, right? Abstract it away, as Nico said. Okay, so now that we established what a good API design might look like, how can we measure it, right? So for everything that especially in IT, if you want to say, okay, this is good, the question is, okay, how good is it? And can we improve it? And in order to improve it, you have to measure it. So as we already have seen, the result of that design process is usually a spec, right? So if you're talking about REST API, it's probably an open API spec. If we're talking about a synchronous one, it's probably async API. There's GraphQL schema, there are a bunch of it. But the thing is, this is your contract, this is your design. And so this is the basis for the measurement of any quality level. And as Nico already said, the process of analyzing it, that's called linting. There are quite a few linters out there. And if you go and check it against a set of rules, so we're talking about static analysis, because these specs, these contracts, they don't change, right? So the analysis, you can do it whenever you have a spec ready, and then you can put, I'd say a sticker on it. but you can measure some performance indicators. And as I said, we need these because we need a comparable indicator that we can judge the quality on and that we can track progress against. And what we at Apiida did is we looked at all the different, rule sets that they are, and we try to put the different rules, like what you can check, into different groups. And if you do that, you basically get down, or you come to these three groups, which are security, quality, and compliance. And what we do internally for our customers, and it will be available as part of our products in the future, is to create a score. So for every API design, for every spec, we create a score on security, we create a score on quality, and we create a score on how compliant it is to the corporate rules. And if you do so, now you have something that you can measure, that you can express for every version of your design process, right? So you have the first draft, second draft, third draft, and now you can track the progress, and you can say, okay, we're getting more secure by the day, our quality increases. And to give you an example for quality, one that Nico mentioned is like, don't call it the description of an endpoint, don't call it get the accounts. Okay, everyone knows that because the resource is named accounts and the HTTP verb is get. Okay, so get accounts just isn't of any use. Be more creative, describe what you can do with it. So that will improve your quality rating. When it comes to security, in the contract, there should be the information on how this endpoint is secured. What do you need to present? Do you need to present a token? Do you need to present a password, a certificate, whatever? So if you have that information specified in your spec, this will increase your security rating and so on. So over time, you get a better and better and better spec, right? And then we know what it is, we know how to measure it, and how do we enforce it? And when you want to enforce things, there are basically three goals, or there are goals that have to be fulfilled. So we identified three. So you have something, some kinds of minimum requirements, right? So you don't want to publish bad APIs. You don't want to publish APIs where authentication schema is not described, right? So you don't want to publish APIs that don't have any description at all or any documentation. So you have that one goal, making sure that the minimum requirements are met. Second goal is continuity. You want the quality to stay on top, right? So you don't want to start out good and then get worse and worse and worse with every iteration, because people change the contract, but they don't adjust the documentation or stuff like that, right? So this is the second goal you have. And the third goal, as I said, okay, improve your API design quality over time and make it better, make it better, make it better. And Nico, just some experience from your projects with customers. How do these designs evolve? Is it like, it gets worse with every version, or are the customers really putting in the time to do maintenance and make sure everything's up to date with their designs?
Yeah, I must admit, this is not, how to say, top of our customer minds. Our product actually provides some capability to enforce this. So one way to achieve these goals is to make sure an API doesn't go to production unless it meets certain requirements. You can do that with tools. You can do that by forcing people. Sometimes you need people to peer review those APIs. So has the API got any security in place? Has the API got the right naming convention? So Gravity provides some capability which forces people to go through a review process in order to enforce these goals. But as I must admit, the majority of our customers talking to me, quality and review is not really top of their mind. They're more concerned around security, performance. So that's something absolutely which probably we need to start pushing as well as as a expert in this field. That's something customers actually should look at when, for example, looking for an API management solution. Does that solution help organization to enforce quality, for example, in governance? And that's one of the strengths. But normally, when customers come to us, is not one of the questions they ask to me, to be honest. And that's the reality.
Yeah, that you know, I fully agree on that. So you need to tick the boxes first, and usually these are security. I mean, obviously that's what we are here for, right? So to secure your APIs no matter what. But you know, especially as with a trend to API as products, and you know, more and more business processes really relying on these APIs, and citizen development being a huge area of interest lately. People should focus more on quality, and I agree with you. That's our task to educate people.
Exactly.
So what can you do to reach these goals? And what we have is you can do quality gates. So now that we can measure it and we get a score, what you can do is in your CI/CD pipelines, just don't put these bad designs into production, right? Or if you're using a pull request based approach for your development, don't allow merging of pull requests if quality went down, right? So time after time, you will get better quality scores that way. And another thing that you should do is don't stop at the contract level, but also analyze the created proxies, right? So the flows, as they are called in Gravity, because it's one thing if it's in the contract, but it's another thing if the API really behaves like it is described in the contract. So always make sure that you also check against the implementation, do end-to-end testing. And that is much, much easier when using an API gateway. Hopefully everyone that joined us today is using one. If not, have a look at Gravity. It's a great tool. There are others out there as well, but you know, it's a great starting point, and it just improves your handling of APIs so much. And one thing that I'd like to share at the end, and then we can open it up for a question and answer if there are any. This assessment of API designs, the quality score, security score, compliance score, we'll have that in our product, in our Obsidian platform, which fully integrates with Gravity in the near future. We're currently in closed beta, and the assessments, so these scores, this will be part of our free offering. And for all the participants of this workshop, we offer an exclusive early access of this feature. So if you are interested in giving that a test drive and seeing how your APIs compare, either drop me a line, email is written on the slide, or contact us on LinkedIn. And with having said that, that's the end for me as well. And we open it up for questions.
Thank you, Markus.
Yes, Georgie, I'd love to have one.
with our new mascot. Did you see the post on LinkedIn by Newt?
Yes, I saw it. It's called Newt, right?
No, yeah, Newt, yeah.
Yeah. No, it's lovely. It's lovely. Yeah. I like it very much. Yeah. Okay, all right then. I think then we'll be closing the session, right? So thank you, Nico. Yeah. Was a great experience to do the talk with you today.
Thank you, Markus. Thank you for your time.